midsegment, just like it sounds, is a segment that connects the midpoints of two sides of a triangle. Alright, so there are 3 midsegments per triangle. So the first one goes from one side of the triangle straight to the other, to the midpoint, splitting this side in half and this side in half. And then it connects here and here. So 3 midsegments per triangle. So this creates a couple different theorems. The first theorem is that the midsegments are parallel to their base, meaning segment LN is parallel to segment AB. That's what that symbol means, parallel. It also lets us know that that LN is half of AB. So if AB, let's say AB is 20, LN will be 10. And it looks that way too. AB looks a good bit longer than LN. If a segment joins the midpoints of two sides of a triangle, so if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half of its length. And so that's what we just talked about. This is parallel with this, and LN is half of AB. So that's the first thing you need to memorize. So if I gave you an algebra problem, we could multiply this midsegment by 2 and set it equal to AB, which is 3x minus 8, and I will have you solve for x. These are the types of problems you will be seeing. I could label a triangle and say, what is the length of LN? Well, you do 2 times LN equals 3x minus 8, and then you just solve. And then you would say LN equals 14. And we don't have, it's not labeled as inches or centimeters, so we'll just leave it as that. Plugging x back in. Just depends on what the problem asks. Let's say, what is the length of LN? That is what we just found. So that's how you'll complete that problem. Always multiply the smaller segment by 2 and set it equal to its parallel base. That's the first theorem you need to know. The next theorem with midsegments is that the midsegments are half the lengths of the sides they are parallel to. So they are congruent to half of each of those sides. Again, this is similar to what we just talked about. DF is half the length of AC. So if AC is 20, DF is 10, which means AE is 10. So this whole thing is 20, and so then the parallel midsegment is half that length. And then, of course, AE is 10 and EC is 10. So the midsegment is half the length of the sides they are parallel to. So let's go ahead. Let's say DF is half of AC. DF is half of AC. Then we can also say DF is congruent to AE and DF is congruent to CE. Alright, the next one, let's look at EF. EF right here is parallel to AB, so EF is half of AB. Doesn't AB look a good bit longer than EF? Yes. So EF is going to be congruent to half of AB. So EF is congruent to BD and also congruent to AD. I don't really mind if your letters are, if you put DA, that's fine. All right, moving on. If this midsegment, DE, is parallel with BC, then it's half of BC. So DE is congruent to BF, and also CF. I switched the order of those, but it doesn't matter what order you put any of these in. All right, one more thing. In triangle ABC, all four of the triangles created by the midsegments are congruent. So in triangle ABC, this triangle ADE is congruent DFE, and also this smaller triangle EFC. All four of these triangles are congruent by side-side-side theorem. And we'll talk more about what this means later. This is really what I want you to focus on. And again, I'm going to show you what type of algebra problems you'll be asked from these. But let's go ahead and write our four triangles are congruent. ADE is congruent to triangle EDF. Then I'll do this triangle down here, CEF, and last one up top, triangle BDF. All right, moving on. All right, so we have some algebra problems here on the back that I'll show you, but we're not going to focus too much on the angles, which is what some of this talks about. So we'll skip this bottom half for today. Let's just look at this top one so that we can finish the video in 10 minutes. And I don't even think this one is in our standards since this is talking more about the angles. But let's look at this top problem. The midsegments and the sides are parallel, creating angle relationships. And we'll talk about these parallel lines later in a different, on a different day. So the parallel lines create congruent angles. But today we're just going to focus on the sides. Again, we can look at what's parallel to what. So AB is going to be parallel to EF. AB is parallel to the midsegment EF. It is good to know what is parallel to what. AC is parallel to DF. And last one, DE is parallel to BC. It's whichever base the midsegment is facing is the line it's parallel to. Remember, parallel means across from each other, running at, you know, let's say 6 inches apart, but they never cross or touch. All right, so if I asked you, let's solve for x first, because they want, the question's asking find the perimeter of ABC. The perimeter is adding up the 3 sides. It's the area around. So we need to find all 3 sides. And really, before we even start, if EF is 16, its parallel base is AB, and the theorem says that we can just double this, the 16, double it to get its parallel base. Or we can say BD is 16 and AD is also 16. So the whole thing is going to be 32. So we have this side. Let's now focus on the x's. We're going to say 2 times 2x plus 6 equals 5x minus 20. Remember, DF is half of AC. This is the midsegment that lines up with this base. This is obviously smaller than this. If we double this and set it equal to AC, then we can solve for x. So let's go ahead and FOIL. Okay, so x equals 32. We want the perimeter at the end, so we're going to end up eventually plugging in 32 here and adding the three sides together. But before that, let's go ahead and solve for y the same way. DE is going to be parallel to BC. So what do? I multiply DE by 2 and set it equal to its parallel base. So 2 times 3y minus 7 equals 10y minus 62. Oops, I didn't mean to run off the page there. Okay, so now go ahead and FOIL it out. Add your like terms. I'm going to try to keep things positive, so I'm going to subtract over the, let's subtract over the 6y to start with, and then I'll add over the 62. Adding to your like terms so that we get positive 48 equals 4y. So y equals 12, so then now we can plug this in here and then add up our three sides. So go ahead and do that now. Okay, so I'm plugging in, we have 5 times 32 minus 20, so AC, the whole thing, is 140. Then up top, I'm going to plug in 10 times 12 is 120 minus 62. This is 58. And then we had 32, and then I'm going to add those three numbers together to get my perimeter. 230 is your perimeter and your final answer. So that's the lesson for today. Our mid segments are half the length of their parallel base. That's the main takeaway. The other thing that you don't want to forget is that a mid-segment does split BC in equal parts. So if BF is 5, CF is also 5. Okay, I'll post these filled in notes, and I have some extra practice that will be posted as well. Thank you, guys.